So what you have to do in this case is, can you find a possible equation of the graph shown below? So first you take the vertical asymptotes. There are two vertical asymptotes. So what will that be?
2 and minus 5.
So x is equal to minus 5 and x is 2. So what will the denominator become?
X plus 5.
Y is equal to, denominator will become x plus 5.
X minus 2.
And x minus 2. Now, what will happen in the numerator? Now, numerator is having a horizontal asymptote
at 2, so there would have to be some 2x of something on the top.
Okay, so that will be 2.
And then something.
Let's call this x plus a and x plus b.
Yeah.
Correct? Now, we also know that you can look at the x-intercepts.
Yeah.
Now, see, you know this is touching here. This is touching here.
Yes.
So if it's touching here, what
it has to be x squared.
So what will it be? So can you say y is equal to 2
x squared.
X. What does this be? Minus 2.
Minus 2.
So x plus 2 squared.
Yeah. You're talking about this value.
X plus 2
x
squared.
Plus 2 squared.
And what will happen? X plus b.
Yeah.
Correct?
Yes.
Upon
x plus b.
X plus 5 and x minus 2.
Now
we also know there's one more x-intercept.
Yeah, at 5.
5.
So you can make that x minus 5.
So you can make this as x minus 5.
Because you know your numerators for the x-intercepts and then your denominators for the...
But now the problem is with your y-intercept.
Because
the y-intercept is what? Minus 2.
Oh.
Y-intercept is minus 2, no? You can see that.
Yeah.
So how will you adjust the y-intercept?
So
how do you find the y-intercept? Put your x as 0.
It's 0, yeah.
Correct? So this is 4, 2 square, correct? Minus 5 upon 5 and minus 2, correct? So minus cancels, 5 cancels, 2 2s are. So that's 4 we are getting. So what is going to happen is we'll need one more. What do we need? Minus 2, no?
Yeah.
So suppose if there is one more x minus 2 square. Correct? If I x minus 2 square, so that will be 4. So now do it again.
So 0.
So y is equal to. Are you understanding what am I doing?
Yeah.
How am I fine tuning?
I don't understand why you squared it, but
I squared it. Why? Because if the power of the numerator is greater than the denominator, you'll get an oblique asymptote. This is not having an oblique asymptote.
Okay, I was gonna say that.
So there's a cubic and cubic. So down also has to be cubic.
Right.
So now suppose if I put this as 0, what?
So you get 4.
Y-intercept.
4 minus 5.
So y is equal to, now say this pencil is not charged. Okay.
2 times 4 minus
y. Yeah, so check. This pencil is not charged. Y is equal to 2. 0 plus 2 square is 4.
4.
Minus 5. Or x plus 5 is 5. Correct? And 4. Because minus 2 square is 4.
Minus 2 squared is 4, yeah.
Cancel. So minus 2. Perfect. So that's my answer.
Okay. Alright. I get where if the numerator it has to be equal to the denominator of the powers, but I still don't get why you squared the x minus 2. Like, it's just something you do. Why didn't you square the x plus 5?
You could have squared that also, but then it won't give you minus 2. So I thought let me start with the squaring of the smaller number.
Okay. It's just something
it's just elimination.
Okay.
It's just elimination. Method of elimination.
Okay. And you need to find the y-intercept. Like, it needs to match.
Yeah. It should. The x-intercept also should match.
Okay.
So the numerator, you're generating the numerator from the x-intercepts. So your minus 2 was a repeating root. So that became x plus 2 the whole square.
Right.
Correct? X minus 5, because this 5 is there, it's cutting here at 5.
Yeah.
So that became x minus 5. Correct? Y is equal to 2, so this becomes a coefficient.
Right.
Now, it seems that the vertical asymptotes are this and this. X is equal to x plus 5 and x minus x, yeah, this is 2, no? So x minus 2. But if this was square and this wasn't square, you'll get oblique asymptotic.
Right. Because that's
So,
weird. So you just squared. Okay.
So then you have to square one of them.
Okay. Alright.
So because there's a minus 2 surviving, because when we put that,
Yeah.
so I wanted a minus sign to survive in the numerator. So I squared this.
Okay.
That's what, it's like a thing I use.
Okay.
Okay. Lesson 19, polynomial and rational inequalities. We start off with a very complicated looking graph to review, check your understanding of solving equations and inequalities graphically. Okay, so these are various graphs which are there. So let's try to identify each of them. Y is equal to fx is this graph. Correct? Y is equal to fx is this graph. Okay, let me just make different colors. That will help. No, because what's happening is this is not helping our case.
Yeah, it's very...
It looks too monotonous and difficult to spot.
Yeah.
So what will I do is I'll go on this overhead. So that's your hx.
Yeah.
This is my hx.
Okay.
Okay. Then I'll use this green for fx. This green is my fx. Okay. So now you can see some differentiation, correct?
Yeah.
Isn't it?
Yeah.
And the black one is the gx.
They're all the same.
So there are 3 sets of graphs. Basically.
Okay.
Now, which function appears to be a polynomial of even degree?
hx.
How do you know that?
Because it's
a quadratic.
Quadratic, yeah.
Remember that even degree function will have odd turning points. Odd turning points.
Yeah.
There's one turning point only, the top, the peak.
Right, yeah.
Odd degree.
What do you mean by odd turning points? Like
suppose if I give you
an odd number?
Odd number.
Oh, like at 1.
So x square will have one turning point. So anything in x raised to 4, a polynomial in x raised to 4 will have 3 turning points. 1, 2, 3.
Oh, yes. Because it's that minus 1. I remember
that minus
n
1.
minus 1.
Yeah, n minus 1 number of turning points.
Okay, right.
So, which is the odd degree?
Odd degree, I'd say fx.
Fx, yeah, that's a cubic function.
Yeah.
Then?
And then rational is gx.
Rational is gx. Fine?
Yeah.
Now, estimate the solution fx is equal to gx. So, what do you mean by fx is equal to gx?
You're equating two equations.
Correct. So, what will your answer be? Where they meet.
Oh, right. Okay.
fx and gx.
So where's
fx is green.
I see now.
And gx is
black.
Is your black.
So there it's intersecting.
Black.
And
so green is equal to black.
Yeah.
So green and black will be, let's say, minus 3.2.
Yeah.
Correct? Approximately this.
Yeah.
Then, so this is
but there's more than one.
No, you write all of them. No?
Oh,
one.
Okay.
This is 1.
And then there's like 0.
Here also.
Oh, yeah, there. That's
so
minus 1.
Minus 1.2.
Yeah.
Correct?
Mm-hmm.
Then it is
0.
Here.
Mm-hmm.
0.2.
Yeah.
Correct? Then it is, we said green, no?
Yeah, that's
green is equal to black. Yeah.
Minus
2.1 or 2.2, whatever.
Oh yeah, sorry, 1, yeah.
So in exams, if you have this, now you can use different colors.
Yeah, wait, why is it 2.2? Oh, sorry, because you're looking at the x value. Sorry, yes. Okay, yeah, sorry.
So when you write the solution, you have to write the x values.
Okay.
fx is equal to hx. What's my fx now?
fx is your cubic and gx is your black.
fx is
green.
Green and red.
Mm-hmm.
Green is equal to red. So green is equal to red.
So
one second. Okay. Green is equal to red.
minus 3.
Yeah,
minus
little
2.8.
minus 2.8, 2.9, whatever. So minus 2.8.
Yeah.
Green is equal to red is here.
Minus 1. No.
Minus 0.8.
Yeah.
It's just before that. Correct? And here.
3.7.
More than that, bro.
3.8.
That's okay, whatever.
Oh, wait, no, sorry. I was looking at it wrong. Like 3.9.
Green is equal to red. 3.9.
Yeah.
Sure, will do. 3.9. Then GX is equal to HX.
Okay.
GX
So
is
the
black.
gray.
Black.
Black, yeah.
Black is equal to that's
Red.
black. HX is
Red.
Black.
Minus
Black and red here.
4.4.
Minus 4.4. Okay. Black is equal to red here.
Yeah. Minus 1.2.
Black is equal to, so let's go on the red only. That's it.
Yeah.
2 solutions.
Nice.
it's not tough, but it's you have to see properly.
Yeah.
Estimate the equation of the vertical asymptote of Gx.
X cannot equal to minus 1.
So equation of the vertical asymptote for Gx. Gx is the black one. So here we have, this is, let's say this minus 1. So minus 1.4.
Yeah, 1.4, yeah.
And here minus 2.2.
Mm-hmm.
Correct? Approximately.
Yeah.
Estimate the solution of the inequalities when your fx is greater than or equal to hx. Fx is greater than or equal to hx. So when the fx is your green is above red.
From
here
minus,
to here.
yeah.
From here to here. Correct?
Mm-hmm.
And beyond this, green is above red. So what is this? What will you call this value?
Minus 3.2. No. 2.8.
Yeah.
0.7.
Yeah. So minus 2.8 is less than or equal to x is less than, what does that say? You said 0.7, na?
Yeah.
0.7 union. So this is green is above red,
Mm-hmm.
because fx is greater than or equal to hx. So this
union x after 3. No.
This is 3 is here.
Mm-hmm. So then
Here.
3.9.
9. So or x is greater than or equal to 3.9. You followed how to write this answer? Huh? You see where your green is above red.
Mm-hmm.
Now this is your green is below black. Correct? Fx is less than gx. So fx is less than gx.
When is it less than gx?
So fx
at minus 3.9.
No. Here, this one.
When is it less than gx?
So green, fx is green.
Yeah.
Green below, you have to see green below black.
From minus like 3.9. Is that 3.9?
Okay, minus 3 is here. Minus 3.9 would be here.
So when is it? Oh, when black is below green?
So
oh, sorry, I was looking at the wrong way.
Yeah. So what is that?
That's like 3.2.
Yeah. So minus 3.2 is less. X is less than that, correct?
Yeah.
X is less than minus 3.2. What else? Green is below black. Green is here.
Yeah.
Correct?
Mm-hmm.
Your green again goes below black.
So that's like 1 to 2 kind of.
Here, what
Yeah.
is this?
Like 0.2.
One.
Okay, 0.1.
0.1,
Yeah.
0.2, yeah. Up to?
Up to 1.8. No, 2. 2 on the dot.
Yeah. 2.2. Correct?
2.2.
2.2 or 2.1, whatever
okay,
you call
yeah.
it. Okay, and then, union, there's one more. Here also it continues.
Oh, yeah.
Because the green is still below black till here. Union 2.2 is less than x is less than
4.1.
4.1. You understanding?
Yeah, it's easy.
It's easy. It's just you see when
weird.
But there's a vertical asymptote at 2.2, no? So we have to break that solution over there.
Yeah, right.
So we broke the solution over there because of that.
Just something to remember.
Yeah, so that's a vertical asymptote. Therefore you broke it. Then what is fx? Fx is green.
Yeah.
Green is below black, below red. Green is fx, huh? Green is below black. Green is below black. And black is below red.
Like here? Wait.
Green is below black. Correct? And black is below red.
Here. No, below.
Means first on top you need to have green. Then you need to have black. So top you need to have a green. So green is top over here. Correct? Then we need to have a black. Then this is not black. So green, black you have to go to. Green, black, no. Green, black, and then red below that. Green, black, red. Green, black, red. Green, black, red. Anywhere else?
No.
No, only here. Green, black, red. Yeah. So here this part.
Yeah.
Here this part. From this part onwards.
Like 3.9.
No, here.
Oh, 4.1.
So x is greater than or equal to 4.1. So therefore it's good you need to put colors, otherwise though you will all will look the same. So after that problem you may be relieved to go back to the algebraic methods. Yeah, we are indeed relieved because there's too much to see.
Yeah.
Now how do you solve this using an algebraic method? Solve this and graph the solution under multiple. So this is very simple. You just solve like an equation.
So you equate them, right?
And then, so you just open the bracket. Correct? Open the bracket. Transfer all terms with x on one side.
To 6x.
Transfer all the numbers on the other side.
Minus. Yeah.
6x is greater than 1. Correct? So x is greater than 1 6.
Yeah.
Okay. Graph this on a number line. So you do a number line. 0, 1, 2, 3, 4. Minus 1, minus 2. X is greater than 1 6th. So take 1 6th. And x is greater than 1 6th. X can take any value greater than 1 6th.
Okay.
So 1 6th is approximately there. You divide the distance between 0 and 1 into 6 parts and you take the first part.
Okay. Alright.
A student is trying to solve the inequality 2x is less than or equal to x squared minus 3. What is wrong with the student's solution below? Work below. Hint. What do the graphs look like? What is the correct solution? Acha, is this wrong or right?
What do you do with the x cubed?
Overall you say.
Is one of them correct? Or no, he said...
No, overall. This is overall working.
Yeah, what's wrong?
What's wrong in this working?
Well...
So what did he do over here? He took this 2x on the other side.
Oh wait, sorry. I was reading that as x cubed. It's x squared.
It's x squared.
So he brought the x squared. He kept the x, so he brought the minus 2x.
Yeah, he brought the 2x on the other side as minus 2x.
Yeah.
Which is fine.
Yeah.
So this step is right. Then what did you do? Factorize it.
Yeah, so x squared.
Correct. So this
minus, that's correct.
Now what is wrong in this? Is this wrong?
Yeah, because...
This is wrong.
Yeah.
You can't do this.
Yeah.
So what you need to do is...
work it ourselves, basically.
No. What you need to do is... you need to draw a number line and mark the solutions. Minus 1 and 3. Correct now? Because these are the factors.
Yeah.
The solution will be minus 1 and 3. What kind of parabola is this? Smiley face or sad face?
Smiley face.
Smiley face. This is your parabola.
Now
you have to see when this parabola is greater than or equal to 0. So, means it's above. This is below. This is above. So, when is the parabola greater than or equal to 0?
Before minus 1 or after 3?
Yeah, so x is greater than, less than equal to minus 1 or x is greater than equal to 3.
Okay.
This is how you need to do. Use your graphic calculator to solve the inequality. This is x cube minus 4x square plus 4x is less than equal to 0. Include a sketch which illustrates the answer. In what quadrants does y value have a value below 0? So let's do that. Whenever you're solving this, the first thing you can do is, you can make it equal to 0. Okay. To make it easier, thoda.
Yeah.
To get the intercepts.
Yeah.
So you have x cube minus 4x square plus 4x, make it equal to 0. Now remove x common.
So x squared minus 4x plus 4.
Okay. Factorize this. This is x minus 2
x minus 2 squared, yeah.
So what are my solutions? X is equal to 0
or 2.
Or x is equal to 2. Now
and
this is
bouncing at 2.
This is bouncing at 2. This is a repeated root. It's bouncing at 2. Correct. Repeated roots. So what's going to happen is, if I draw my graph, this is cutting.
At 0. And bouncing at 2.
Bouncing at 2. 0. This is your x. This is your y.
Oh. But wait, what's the question asking?
The question is asking you to solve. Now make it less than or equal to 0. So when is your x cube minus 4x square plus 4x less than or equal to 0? So when is your y negative? Y
is negative before 0.
So x is less than 0, less than or equal to 0.
Yeah.
Correct?
That's it. When it's negative.
And it's also negative. It's also equal to 2, no? X is also equal to 2 will also make it equal to 0. It's cutting.
But that's not...
Yeah, it's a solution, no?
Oh, right. We're just looking for solutions.
We're looking for solutions. So either you need to put in something that when you substitute in the inequality, it should either give you less than 0 or equal to 0.
Okay.
So when I put in equal to 2, it will give me equal to 0.
Wait. Less than 0 would be negative. And why have you written that? Why have you not just written the 2 roots? Because it's saying...
Here this is negative.
Yeah.
Correct?
Why is that important?
Here because it's less than.
Oh, it's asking what values are less than and equal to 0. And it's equal to 0 at 2.
At 0 and 2.
At 0 and 2. And it's less than 0 before 0. Okay. Makes sense. Okay. It's because of that sign. Less than equal to.
Yeah. Because of the sign less than.
Yeah.
Similarly, you'll be doing this over here. So knowledge of cubic. So tell me what will my roots be?
So for this it would be 0, minus 3 and 4 and it's cutting at all of them.
Will it be like this or like this? Will it be
it would be the first one. Sorry, the second one because it's negative.
Correct, it will be the second one because it's negative.
Yeah.
So that means, what will you do is, so minus 3, 0,
and 4.
4. Okay, so it's like this.
So then it cuts at -3, cuts at 0, cuts at 4. Yeah, this is all easy.
Now, when is it greater than or equal to 0?
When is it greater or equal to 0? It's equal to 0 at -3, 0, and 4.
Yeah.
And it's greater than 0 from 0 and before 4.
Greater than or equal to 0. Also, can I say x is less than or equal to -3? This part.
Oh yeah, sorry, I didn't see that.
And between? Between what?
In between 0 and 4. Yeah.
Oh, so if you are using your bracket notation, you know that, no?
Yeah.
You can do this, or you can do what?
0.
Minus infinity, -3, correct?
Mm-hmm.
Union.
I honestly prefer that way,
This way.
the union way.
This
but
way.
but I need to learn.
But then both you should know. Be open to both.
Yeah. Okay.
But this is also fine. I mean.
Yeah.
This one.
So there's a cut at -3.
Correct.
And it bounces at 1.
So root -3 bounce at 1. Okay.
Mm-hmm. And it's positive, so it start from the bottom. So it cuts at -3.
Correct?
Wait. But it's positive, no?
Oh. It's positive. So, I made a mistake. Yeah, this way.
Okay.
It's positive cubic.
Yeah.
So when is it greater than 0?
From -3 to infinity.
No.
Oh, sorry, because no, -3, comma 1, and then 1 to infinity. Because from
-3, 1, union 1 to infinity.
Yeah. So I can write it like that easily, but I'm struggling with the scientific notation.
Then it's okay. You can write like this.
Are you sure? On
Yeah,
this, I'm
yeah,
gonna write
yeah,
it
yeah,
this?
yeah, yeah. Perfect.
Okay.
And IB also they'll accept. But 1 is not included, huh? So
Yeah.
you need to know that because
Yeah.
it's not equal to 0.
Yeah.
It's greater than 0. So like
Yeah.
last time I had equal to 0.
Right.
The reasoning used in question 5 can be written in algebraic form using intervals and test points. So yeah, what are they trying to say is you have what we call the sign diagram. Have you done the sign diagram earlier?
Yeah.
So what they say is once you get the root now,
This is
minus
quadrant 4.
0, 4, correct? Then what's your function? The function is minus 2x, x plus 3, x minus 4. That's my function. This is my function for this for this. Now you take a test value. So what test value you take in before -3?
-5.
-5. So f of -5 will be -2 minus 5 minus 5 plus 3 5 minus 4. Correct? So 5 2s are 10. 10 and this is 3, no? So 10 into -2, correct? Into 1. So -20. So this is negative.
Wait. Why is it 5 minus 4? Isn't it -5 minus 4?
-5 minus 4, yes. -5 minus 4 will be what? -9.
-9.
So that's how much? Plus 180.
Mm-hmm.
So positive.
Yeah.
So this is positive.
Okay.
Like that you go on doing basically.
And then you check.
So you'll get
you take
so you'll get
-2.
positive, huh? You'll get positive because this below you'll get negative. You have to show your working.
And then you try -2.
Positive and negative. This is what you'll get. Similarly, you have to do for the other one. Take a test value basically.
Easy.
But it's always better to know the graph. Then the next one is solve the inequality using intervals and test points. Check your answer graphically. So intervals and checkpoints. Come on, test points.
Okay.
So in this case,
It'd be x minus 1.
So x minus 1 upon x square
X
minus 4, you make it equal to 0.
Yeah.
So x minus 1 is equal to 0. So x is equal to 1. Yeah? Where's your vertical asymptote?
Vertical asymptote x squared minus 4, so 2 and minus 2. And there's a horizontal asymptote at 0.
Yeah. Y is equal to 1. But that's not important for us.
Wait, sorry. What do you mean? Isn't it 0? Because the denominator is greater than the numerator. I know it's not important.
Oh, yeah.
You said 1.
Sorry,
Yeah.
by mistake.
0,
No,
0.
0.
Yeah.
You're right.
Okay.
Y is equal to 0, yes.
Y is equal, yeah.
Correct. So x is equal to 1. So this is my so x is equal to 1. So you put that. My vertical asymptote, now you put a dotted line. Huh? Because that is excluded. Minus 2.
Yeah.
And which is the other vertical asymptote?
2.
Are you following that?
Yeah.
So you mark the roots. You mark the roots and or the zeros as we call it. You mark the zeros and the vertical asymptote on a number line like this.
And then you take
a test values.
You take minus 3.
So minus 3. So f of x is equal to minus 3 minus 1 minus 3 square minus 4. So minus 4 upon 5. That's minus 0.2. Correct? So this is negative.
Yeah, minus 0.2.
Then this one, take a value between minus 2 and 1, 0. So 0 minus 1 upon 0 minus 4, which is positive, 1/4.
Yeah.
So positive, correct? Then you take a value between 1 and 2.
So 1.5.
1.5. So 1.5 minus 1 upon 1.5 to 2.25 minus 4. So 0.5 upon minus point. What does this mean? What is 4 minus? 2.25 minus 4 is what?
Minus 1.75.
Correct? So anyway, it will be negative. Correct? Yeah. Because positive. Yeah. F3. Rashmi, I think I'm going to F3 all do it. So F3 is 3
2
minus
upon
1
5.
upon 9 minus 4, 2 over 5, positive. Like that. So for rational equation, you need to identify the vertical asymptotes because that is important. Because the sign of the rational graph may change. See, it's changing along the vertical asymptote. But remember that the value is excluded from the domain. Obviously, because it's a vertical asymptote, it will be excluded. It's removed from the domain of the function.
So it's asking for the domain, I have to write it separately with union.
Now, so what's your answer then? Final answer.
So where is it greater or equal to 0?
Yeah.
From minus 2 to 1.
Minus 2 to 1 will be included?
Oh wait, no. It won't be 0.
1 will be included, no?
Yeah, sorry, 1 will be included, yeah.
Minus 2 won't be included.
Because it's not.
It's not a dotted line.
Yeah. And then
union.
2 union with the square brackets, yeah, to infinity. Nice.
A lot of things to consider,
but it's easy actually.
It's easy, yeah. Summary: solving polynomials and rational inequalities using intervals and tests. So write the inequalities so that the polynomial rational equation is on the left hand side, correct? And 0 on the right hand side. 0 on the right side. For rational expression, make sure that left side is written as a single fraction. As a single fraction, and take note of the domain, vertical asymptote. Determine the real numbers at which the expression fx equals 0. If rational included numbers that are excluded from the domain, we remove that vertical asymptote. Use step 3 to separate the number lines into intervals. You don't intervals basically.
Yeah.
Dash, dash. We break it up.
And then another interval is your x-intercept, right?
Yeah. Yeah, that we saw, no?
Yeah.
That's your first step we said, no?
Yeah.
See, here, second step. Real number, that means the expression equals 0.
Yeah.
That's
And
your
wait, what's step 1? Write the inequalities of the
in a single fraction.
Single fraction. Okay.
Select a test number in each interval and evaluate the number. If the value of f is positive, then fx is greater than 0. Correct?
Right.
If f is negative, then fx is less than 0.
Makes
Correct?
sense.
Include solutions of fx is equal to 0 if signs less than equal to are there. Because you have to take
Yeah.
Yeah.
So like
unless the value is excluded, like an asymptote.
So if there's an x-intercept at -3, I put -3.
Yeah. So solve algebraically. How do you do this? Tell me.
So
First thing, what will you do?
equate it to 0.
No, yeah, equate it, but how? You get all terms on one side.
One side, yeah.
Combine this in a single fraction.
So x plus 2 minus, yeah. Yeah.
So 3x minus 5 minus 2x minus 4 upon x plus 2 is less than or equal to 0. Correct?
And then you simplify. So x minus 9 upon x plus 2. And then you equate x plus 9 equal to 0.
So x minus 9 is equal to 0.
So x is equal to 9.
That's my 0.
And then you do x plus 2
Correct?
is equal to
Vertical
0.
asymptote.
Yeah.
X is equal to minus 2. So you have minus 2, 9. So minus 2 is a vertical asymptote. This is your 0. Correct?
And then you take
Now
the
we take a
value,
test value.
minus 3.
So minus 3. So f of minus 3
would be.
You put in minus 3 minus 9 upon minus 3 plus
Minus.
2. Correct? So minus 12 upon minus 1, which is 12.
Yeah.
So positive.
Oh, yeah, it is positive.
I'm putting it here, no?
Right.
Because we are using the simplified equation. No?
Right, yeah. And then you can take 5.
0.
0, sorry.
Let's take easy now.
Wait, how come 0? Oh, yeah, sorry, 0.
Because minus 2 and
Yeah, sorry, I thought it was 2 for a second.
So what is that? Negative. Correct? Now
Yeah.
minus 9 by 2. So negative. Then above 9,
10.
10.
15.
So 10 minus 9 upon 10 plus 2, that's 1 over 12. Correct?
Yeah,
That's what? Positive.
positive. Okay.
So what's my answer?
So where is it where is it less than or equal to 2? So
Where's it negative basically?
Where
Because
is it
now
negative?
you look at this because we transformed it. No?
between minus 2 and 9.
Yeah. So minus 2 included or excluded?
Excluded.
9?
Included. Okay, I get it. It's very easy. I just need to learn the inequality way of writing.
Now, solving rational inequalities. To solve rational inequality algebraically, get one side of the inequality equal to 0. Do not cross multiply. You can't tell whether multiplying by negative or positive number. So you do not cross multiply. That's
Okay.
basically don't cross multiply ever. Use a common denominator to write in the form px upon qx. Factor the numerator and denominator if possible.
Right.
Use sign diagram and test points to solve the inequality. Same as what we did.
Okay. Same exact thing.
Same as that thing. So all these are same as that thing.
Okay.
So that we'll do. You can do this for your homework then.
Okay.
Same as the last thing that we did.
Yeah.
Just
it's
follow
easy.
the steps.
Okay.